Hi, this is Dr. Riley, and you're listening to the second of two different modules discussing significant figures. In the first module, we defined what a significant figure was and discussed uncertainty in measurements. In this module, we're going to be using significant figures properly as we conduct calculations. So you should recall that in most experiments you'll be doing in the chemistry lab, you'll be making several different kinds of measurements. Some will be made more precisely than others, largely because of using different tools in the lab. And so when you do a calculation that's based on multiple measurements, your final answer can be no more precise than the least precise amount of information that went into the calculation. This is really the rule that governs all of the calculations we're going to be doing today. So if we're going to be limiting ourselves to a certain number of significant figures, we need to round our answers. So I'm going to start our conversation with a discussion of how to round our numbers properly and looking at whether we increase or keep them the same. Then we're going to get into what to do with your numbers when you're doing multiplication and division or addition and subtraction. There are different rules for each of these mathematical operations. Because we're doing calculations, I would strongly encourage you to take out a pencil and paper at this point so you can follow along and work on these problems yourselves. Feel free to pause the video at any point so you can work the problems over and over on your own. So if we're rounding, we simply need to decide whether the last digit that we retain is left alone or if it's increased by 1. That's really the only question we're asking. And the only time when you increase that last digit by 1 is if the digit following it is 5 or greater. Let's jump in and put this into practice. I want you to round each of the following numbers to 3 significant figures. The first one has a lot more than 3. The way I approach a number like this is by simply writing down the 3 digits that I need plus 1 extra, as written on the left. Then I look at that final digit. The last digit that I retain is the 8. I'm just deciding whether to make that a 9 or to leave that an 8. In this case, because the last digit is a 2 following it, I'm going to leave it alone. It doesn't get rounded up. We just leave it at 4.68. That's 3 significant figures. The next number is 186.7. It has 4 significant figures starting off. So we simply need to look at the last digit retained, which will be a 6. The following digit is a 7. So in this case, because 7 is greater than or equal to a 5, the correctly rounded number would actually be 187. We do need to round up in this case. Now the next example is an interesting one. We're looking at the number 1.299, and again, we need to take this to 3 significant figures. 1, 2, 3. So if we look at the last digit, we can all agree that that is definitely 5 or greater. But what is it going to do the digit here when we round up? Well, it makes that 9 a 10, technically. So this is going to translate into increasing 2 different digits in the final answer. So the correct answer for this rounding is 1.30. You increase this 9 to a 0 and increase this 2 to a 3. Effectively, you're increasing this entire number by 1 because of the rounding. And if you recall the rules of significant digits, this last place here, this 0, is to the right of a decimal place. Therefore, it is a significant number. This has 3 significant figures. Now, the last example is sitting here with 5 significant figures as written. Again, we need to take it down to 3. So let's look at writing down 16.0 and then 1 more digit. When you look at it this way, it seems pretty clear. This does not need to change. The 0 retains its original existence because the 4 is not 5 or greater. But if you looked at the number here and you didn't approach it the way I have it written, you may be tempted to round that number up to a 5, and if you rounded that to a 5, you may want to round the 10th place to a 1. That is incorrect. You don't want to do multiple acts of rounding for a single number. All you do is look at the number that is immediately after the position you retain. This is the number and the only number that decides whether you round or not. The correct answer to that last problem is 16.0. And now that you're adept at rounding, let's actually do some multiplication and division. The number of significant figures in your final answer is going to be determined by the quantity with the fewest sig figs. So the way I approach these problems is by beginning to simply set up the math, then I'm going to look at sig figs at the very end. So let's look at this. The question is, use the equation D equals m over v to calculate the density D of a metal that has a mass of 4.72 grams and a volume of 0.25 milliliters. That's simple enough. When you have your problem translated from the word problem and written out like this, the next step is to simply put this into your calculator to get your final answer. So when I enter this into my calculator, I get 18.88 on my display. While this is mathematically correct, if you left the answer like this, it's still missing two things. The first one is it's actually missing its units. Don't forget to put the units on your answers. But even more, it's carrying much more precision in it than there was in either, actually, of the two measurements. So your final answer here has 4 significant figures in it. At this point in your calculation, what you need to do is go back to the original problem and look at the number of significant figures in every single measurement that went into the calculation. In this case, there are 2 measurements that went in. The top measurement has 3 significant figures, and the bottom measurement has 2 significant figures. You should recall that this 0 is merely a placeholder because it's to the left of the decimal point. So we have 2 sig figs and 3 sig figs. For multiplication and division, all you have to do is identify the number with the fewest number of significant figures, in this case 2. That is what you will need to round your final answer to. So we have 18.88. I need to take that to 2 sig figs. Following my path from before, I'm just going to write 3 digits out, so I'm not tempted to round twice. And I'm going to look, and in fact, I do need to round up. So my final answer needs to be 19 grams per milliliter in this calculation. When you perform addition and subtraction, the rule of thumb is that the number of decimal places in the answer is determined by the quantity with the fewest digits after the decimal. This is in contrast to multiplication and division. It's best learned when we put it into practice, so let's jump into a problem. If you weigh out 124.01 grams of sodium chloride, and then you add 2.5271 grams of water, what is the total mass of my salt water? Well, the best way to do addition and subtraction, in my opinion, is to simply write them out by hand until you get used to seeing where you need to round your numbers. So in this case, I'm just writing them by hand. You align the decimal places with one number on top of the other. And if you were doing this by hand, you would find that you get 126.5371 grams total. Now, if you counted the number of significant figures in this first one, you'd get 5. If you count the number of significant figures in the second number, you also have 5. But those 2 numbers do not actually contribute to your decision as to where to cut off this final number. In contrast to multiplication division, we are now looking at decimal places. That means you need to go to the last decimal place of the least precise number, which is actually the first one, and that is what you'll use to cut off your final answer. So I like to draw a vertical line so you can really plainly see where you need to cut off your answer. In this case, it's in the hundredths place here because this least precise number is on top. The last step is to determine if we need to round or not. So you need to look at the 7 and say, yes, it's greater than or equal to 5. So the correct answer in this case is 126.54 grams. Now, this also turns out to be 5 significant figures, but that is something of a coincidence. That won't always be the case. I can't stress enough that in addition and subtraction, you need to look at the decimal place to determine where you cut off your final answer. The last problem we're going to do together is a multi-step calculation. I'd like you to calculate the density of a sheet of a polymer that weighs 4.5929 grams and measures 2.8 centimeters wide, 3.9 long, and 0.04326 centimeters thick. If you recall from one of our first problems, density equals mass over volume. So I need to get a mass for my polymer, and that is provided here by a measurement, 4.5929, and I need some sort of volume. And in this case, I'm going to have to actually multiply these numbers to get my volume. So I have to conduct two different mathematical operations in order to get the final answer. I'm going to have to multiply 2.8 times 3.9 times 0.04326. If I look at the units on the measurement, which I should be including, I'm going to put grams on the top and centimeters cubed will be on the bottom. So discussion of the order of operations is the subject of a different module. Here I'm going to assume you can perform the multiplication on the bottom. So what you want to do is, in the next step of the problem, we're just going to rewrite the top, the numerator, 5929 grams. And when I multiply the bottom on my calculator, I get 0.4723992 cubic centimeters. It's really important when you conduct these multi-step calculations to carry all the digits that you possibly can handle throughout the calculation as far as you can. You do not want to round more than once. The only time you want to round is in the very last step of the calculation. That's why I've retained so many more digits here than I actually need in the final answer. It actually introduces error to round it multiple times. So I've done the multiplication in the denominator. The numerator is there. The next step is simply to divide the numerator by the denominator. And so I get in my calculator 9.72497,413. Oh my goodness. The units are grams per cubic centimeter. And now we have to talk about the significant figures. So looking at this carefully, because this was all multiplication division, we need to go to the measurement with the least precise value. And you can see here, two of the measurements only had 2 sig figs, so our answer can only have 2 significant figures. Now is the time when we round it. Looking here, we've got 2 significant figures. We don't need to round up because that 2 is below 5. So your final answer here is 9.7 grams per cubic centimeter.